2, War of the Chosen, and Marvel's Midnight Suns. And now I'm a principal engineer at Midsummer Studios, a local independent game studio. XCOM 2 was in Unreal 3. Marvel's Midnight Suns was in Unreal 4, and at Midsummer we're working with Unreal 5. I also use it for hobby stuff, and I've been doing that in Unreal since 4.16, basically when we started Marvel's Midnight Suns. I have made a number of accepted PRs to the engine, most of them dealing with blueprint work, including the TMAP and TSET for each nodes that are now available in the 5.6 release. And I'm currently the lead of the Baltimore chapter of the Unreal Communities program. And finally, here's some of my contact information. There'll be links to the slides at the end if you don't catch all of this. Much of this is based on a tutorial for Blueprint Nodes that I wrote back in February of 2021, and a GitHub that I made to store some of that. Again, slides will be a link for the slides at the end, so you can grab these pretty easily too. So what are we going to talk about this afternoon? Well, I'll set some basic expectations for what I'm going to be presenting. I'll talk about why this is even a topic worth bothering about. Cover some basic setup that you would need before doing any real work with the custom nodes. I'll cover some really basic functions that you'll have to do to get anything working. The meat of the talk is going to be walking you through my process that I've kind of patterned on for making these nodes really easily. I can spin new ones of these up in a couple of days. I'll talk about, I'll revisit the question of why, using that information to kind of bring it more into concrete and a more interesting example for why, again, you should even care about doing this. So we had the meat. The potatoes are going to be some tips, tricks, and gotchas that will really help you work through making your nodes and getting familiarized with that process. I'll drop a batch of functions that are really useful that you can override to make really helpful nodes, and then the advanced API of another set of functions that are super useful, but in very limited cases, but are really useful to know about. And then there'll be links, questions, and there's some appendices at the end with example code for you to use on your own. So setting some expectations, there's a lot to cover, so we're going to set some boundaries of what this talk is going to be about. First, I'll be talking about Unreal 5. Most of this, if you're still using Unreal 4, applies with some limitations, but will be pretty specific to Unreal 5 feature set. I'm going to try to not make this an API dump. It's just a list of functions, because that's not a very interesting talk. I'm going to call out a lot of function names just so that you're familiar with that they exist and what they might be good for. There'll be some links at the end with the better resources for more details on what those functions do, what their parameters are for that kind of thing. There's a really, blueprints are just a subset of what Unreal offers for editor node graphs. Some of what I'll talk about is going to be applicable to those, but there's a larger world for how those work and are set up, that if you were to make a fully custom graph node editor, you would have to do significantly more work than what I'm going to be presenting here. What we're going to be doing, if you're familiar with Blueprint at all, is writing blueprint macros, just from C++. If you kind of squint at what I'm going to present, you're going to be able to see a lot of what looks kind of like writing doing blueprint, but in code, which sounds mental, but it'll make a lot more sense as we go along. There's these two things, this F node handling functor thing that does the direct blueprint virtual machine bytecode. There's an entire another talk about this, and we're going to be very specific about doing the macro version of these and not the direct bytecode. There's also entirely another talk that we can do where we talk about Slate and how you can use Slate to customize the blueprint behavior of your nodes. But again, that's another talk entirely. This is going to be kind of technical for you to go off and do on your own. I'm hoping that even the non-programmers in here are going to get something out of this, even if it's just some ideas for what your teammates who are programmers could do to support you as a developer to make blueprints easier to use. Hopefully you can give them a link to this talk and it'll help them do those things faster. So why should we even bother with these? It's going to be kind of technical. This is an important thing to get off the bat. Blueprint callable functions do a lot. It's one of the foundations of getting blueprint working, but they are pretty basic. Markup does a lot. You can do multiple, but it has its limits. You can't do multiple execution triggers in the same thing like you would for by triggers multiple times. You can't do that from any function. There's also custom thunks that add a lot more power to blueprint functions, such as wildcards, dealing with collections, but ultimately they're still limited by what you can do with view functions. This is another place where you could do an entire another talk about all this gobbledygook for doing custom thunks. For now, we're just going to classify these as part of view functions and limitations for view functions. So what are some of the new tools that you can do if you start making blueprint nodes from C++? Well, you can do dynamic pins. This is the spawn actor node from the engine, and as you select the class, it changes what pins become available based on the actor markup. You can change the types of pins that are already there. This is the for loop node that I mentioned before. The key and the value pins on the output change based on what the input pin of the map is so that they match all the time. You could configure node behavior using the details panel. Normally the details panel is not around when you're making blueprint nodes. In this case, we've got the switch on gameplay tag node where the details panel does let you configure the tags that you're able to switch from. All the switch nodes will have some details panel, and you'll be able to add those to your blueprint node. You can do custom async nodes instead of using the built-in blueprint async stuff that Epic provides. In this case, you can see these multiple exec pins all with different output parameters, which the basic node doesn't support right now. You can take direct control of what pin connections are available in ways that might not be accessible in other ways, even to the point of saying, no, you can't make any connections to this pin if it should always be specified in one of those inline parameter fields. You can fine-tune some of the placement controls, kind of like protected functions. So you can control what graphs your blueprint node is placed in. Maybe it can only be placed in graphs of a certain child class. Maybe it can only be placed in the event graph. Maybe it can only be placed in function graphs. But you have a lot of control there. And there's a lot more that you'll be able to do, that you could do with custom nodes. So now some basic setup for what you're going to do. To start with, you'll need an uncooked only module. These modules are loaded by the editor, by the cooker, and by standalone. Standalone is when you run the editor with a dash game as command line parameter. It kind of runs it. It looks like a cooked build, but it's still running the editor in the background. Because we need it in standalone, they can't be in editor modules. So that's the limiting. That's one of the reasons why we have to put it in this uncooked module. Blueprint Graph and Unreal Ed are a couple of key dependencies that you're almost guaranteed that your module is going to need. And both of these prevent you from putting it into a runtime module. These are editor-only modules and the build process is going to complain if your runtime module has references to these things. Personally, when I make new plugins or games, I just make a runtime, an uncooked only, and an editor module just right up front. There's no real downside to having some extra modules that are empty hanging around, but it means that when I want to go do something with editor or I want to make custom nodes, I don't have to divert my attention to making these module things first, but it's up to you and how you and the order you want to spend your time. There's no reason, if you have a project already, to go out and add uncooked modules to all of your plugins immediately. I just do that for new ones because I like making new print nodes, so I'll put those around already. So a few of the basic functions that you're going to need to know about just to get the bare minimum out of Blueprint nodes. This function is going to be one that you override that is making. This is the guts of the node where the compiler will use to replace your node with nodes that will actually be compiled into that direct bytecode. This is a weird function that you'll always override to return true. It's just how you set up these Blueprint macro nodes. That basically tells the compiler that, hey, it's okay that this isn't attached to anything after the compilation process. You can ignore it. This get menu actions is what puts it into the right-click menu that you use to place down Blueprint nodes. So if you're not overriding this function, it'll be very hard to place down your node. And then there's a bunch of different display customization functions that you can use that all kind of match up with some kind of markup that you would have done on a U function in order to find it either on the node itself or in that UI for placing the node on the Blueprint graph. So my process, I am going to be using this for each node as an example because it has to be done through custom Blueprint node. I won't be sharing all the code here, but it's available both on my GitHub as well as in the 5.6 version of the engine. And this is a really great example because it has multiple wildcards, which Blueprint macros only support one wildcard if you do it in an actual Blueprint macro. But we need two of them. Custom functions can do this. Tmaps have plenty of Blueprint callable functions that support both of these. So custom functions could do this part. The dynamic pin types need to use the input from the map in order to inform the types of the key and value. Again, Blueprint macros can support this for one type, but we need two. Again, the custom functions and tmap functions do this, so we still don't quite need a custom Blueprint node. But we have a repeated execution functions, which is the loop bind. It's going to trigger over and over and over again for each entry in the array. And you can't do this with a U function at all. Even the T array for each is a Blueprint macro in order to get around this limitation. So combined together, you have to do this in a custom node to get it to work. So we'll start by setting up a bit of a framework of where we're going to be doing all of this work. Starting off with new files and this loc text namespace macro. This macro is for localization purposes, which sounds weird to be doing in the editor. It's just kind of how they get done. The Epic ones all do this. You have a define of this loc text namespace to a string at the top of your file, and then you undefine it at the bottom of the file. You may have seen it in plenty of other places in C++ if you're doing any localization or player-facing strings. But it makes it a lot easier to then copy-paste code around because you can reuse some of the same localization string keys and just change what they have to. We're going to make a new class. This is just like any other UObject declaration in the engine. We're going to be deriving from this UK2 node. There are other ones that you can derive from, but this is the lowest level one that you would derive from to get something working with blueprints. We'll do some empty and basic overrides for some of the functions I called out earlier, as well as the visual elements that you're going to use, that you would be using on your node, and the hit menu actions function so that you're able to actually place it on the blueprint kernel. So after you've done all of this, you're going to get something that looks like this, which that looks kind of like a blueprint node, doesn't it? But it's not very useful. So there's still plenty more work to do. Step 2 is usually making all of the pins for me. We start by making a bunch of F names, and these are just the names that the pins are going to have, both by default as the display name, as well as an internal identifier, which is why they're F names. I then make a bunch of accessor functions. We're going to want to get at these functions pretty regularly, and so these are really handy to have. There are built-in functions to the K2 nodes for some of the more common pins, especially exec, which is your input execution pin, and the then pin, which is the output execution pin, which is why we don't need to declare our own here. We're then going to populate code in allocate default pins of calling this create pin function over and over and over again with directions, categories, a name. The direction is going to be in or out. There's really nothing else you can do with these pins. The category you get from the schema, and is going to be things like, is it an exec? Is it a Boolean? Is it a structure? Is it an object? There's a real large variety in just about any of the variables that you would set in Blueprint. You're going to have a category name for. There's also a subcategory object that, depending on which category you're choosing, might be required. So like if you're doing an object pin, that subcategory object will tell you the base class of what kind of classes can connect to that pin. The comments in the schema, where all of the category names are declared, actually have pretty good comments for what the pin category, the subcategory object is that it expects to have. So looking at that code is the best documentation in this case. There's also a bunch of pin properties, flags and stuff that you can set, but you can also set those after you get it back for calling create pin, and a lot of times it's just easier to do that. There's a lot of flags, like whether or not it's a const, whether or not it's a ref, whether or not it's an advanced view property, that are really interesting to use and can help with your node. You can also change the display name if you want it to be something that's not what the default name would be from the F name. You can change tooltips. There's a lot of additional data on the pins you can change to make them useful in different ways. So after we've done all of this, we've got a node that looks like this. And this one looks like a node that you could actually use. We've got the input, we've got the exec line coming in, we've got the completion line going out, we've got a loop body, the keys and the values, the input of the map, and in this case I've built in the break node as an advanced pin, which is why the advanced character is pointing up. Of course, doesn't really do anything yet. It's not gonna, none of the pins are gonna change type, none of what you would expect to have happen is gonna happen, but it at least looks like something that you would place on the blueprint graphic. My next step is building in the UX. Brett, what happened to you?
In the Unreal node editor and the Kismet runtime. Like, how does that work? Like, what is it that the nodes translate into?
Yeah, I've got a slide for that later.
I was just giving you something to vamp on.
Yeah.
I have a question.
Sure.
So you mentioned contributing 15 PRs to
Yeah.
How does it work to contribute to a project that is part of a, like, I'm more used to contributing, the idea behind contributing to open source.
Yeah.
How is it different contributing to a project that is a private, license?
Philosophical, I think, a little bit. You have to have special access to the Unreal GitHub, but they don't gate it too much. You just kind of have request access and you get it. So it's not gated too much. It's mostly so that I guess they make sure that you sign whatever of like, listen, you got to understand anything that you give us that you're going to give us is ours. We're not giving you royalties or something on these things. So other than that, it's kind of philosophical of, is it worth me as a independent developer or somebody developing something to contribute to something that helps our competitors, which I know is like a mindset that some people have, like, I'm paying for Unreal, I'm not going to help my competitors with a better product. That's a way to look at it. But ultimately the process probably isn't a whole lot different. I mean, they're a bigger company, so they take longer. They might be a little more hesitant to take certain kinds of changes because of you as like an individual probably can't test the breadth that they need to do of testing. So a little bit of that. I do it partly because it's just like a lot of the time the fixes, or in this case the for each node. Why did Unreal 4 not ship with a for each node for the TMAP? It's a collection, you want to be able to do that. Why did it not ship with one of those? Which is why I originally wrote it for Midnight Suns. Well, actually, I wrote it at home, brought it into work to use on Midnight Suns. But, so part of it's that, and part of it is sometimes the fixes have to be in the engine. You can do these in a way that, like, you don't have to make any engine changes to create these, which is the great part. Sometimes you have to make engine changes that are you have to make actual engine changes. And sometimes doing a PR can do a couple of things. One, it makes a future engine integration easier because now you don't have to deal with this conflict of engine changes and your own local changes. So whoever's doing the engine upgrade to your company now doesn't have to deal with that, like merging of Epic stuff in your stuff. The other case can be that, at least for internal stuff, saying that I have this change that I'm trying to make to our local version of the engine, I have submitted as a PR, can help your own internal culture a little bit of like, listen, I'm not making a change to the engine because I want to. It is the only way to fix this for what we want to do with the engine, and can make it maybe make people above you in that engineering hierarchy decide, okay, this is an okay thing to change with the future. All right. So we've made a node. It's got a bunch of pins on it. Now we're going to work. Now I tend to work on the UX of having this pin in the blueprint graph. A big part of this is the dynamism of the pins. The dynamics of these pins is one of the biggest reasons I tend to make blueprint nodes. So I want to get this right, and it's usually the reason that I'm making it. So it's like my top priority of getting it right and like what I want to see with that new custom node. Here we can see an input. We've got an input pin mapping an F name of vectors to, or an F name to vectors, and that comes out on the other side. We can do some customization with the output pin names. In this case, you're not going to see it here, and I'll cover it a little more later. I've got some details panels that let me name what those output pins are, so that they're not just key and value, but they're actually more representative of what those map entries are. You can change the name of the map based on the pins, which isn't demonstrated here. Or, like with the spawn actor node, create new pins based entirely on the inputs from other pins. Again, not demonstrated not needed for this particular node. This is when I deal with blueprint save load. A lot of this dynamism stuff can need some extra hooks to make sure that when you load them from blueprint, they're still what they were when you made them and closed the editor down, because that's really important. So that you don't have to, so that they don't only work when placing them down in the editor. Same thing for copy paste. Nodes should be able to be copy pasted, so we want to make sure that that works. It's also a good time to do error handling. You can put in a lot of extra steps to prevent misuse of your node if that's important. There's a validation function that you can actually override, but it doesn't really work for these macro type nodes. So instead, what I tend to do is write an error checking function that I put right there at the top of expand node and early out. And there'll be an example of that kind of skeleton in the appendix for you. A lot of this UX is going to be very node specific for what you want the node to do and how you want it to function. For example, the create event node into the engine, you can double click on that and it'll jump you to wherever that node, whatever function that node would execute. Maybe if you've got a class picker on your node, you want to double click on your node and have it jump to the blueprint that node is now referencing. So there's a lot, so depending on what you're doing with your node, there's a lot of things that can fit into this, and this is the time that I handle it. It's a great time to try to use it. Once you have all these other things working, before you've done any actual implementation of providing any actual real functionality, you could hook it in to the places in your blueprint graph and see what it's like to use it. If it is meeting your needs, if there's improvements that you want to, if there's other things that you want to do, if there's specific error handling that you think it should have. This is a great time to do it now rather than later or after your entire team has put these all over your project. Functionality. This is hopefully what we're here for, right? Have it do something useful. So to start, we're going to use this function here, spawn intermediate node, to create blueprint nodes. This is identical to just kind of placing a blueprint node on your blueprint graph. You will have to do some step to initialize it this is going to be very dependent on the node that you are spawning. And then you've got to manually call allocate default pins after you've done whatever that initialization is. Next, you're going to get all the pins from that node. And then you're going to connect those pins to other pins using one of these two functions here. This is the equivalent to basically dragging the lines between things. Like I said, it's very similar. There's equivalents to like you're making a blueprint graph, doing work in the blueprint graph, and now you're just kind of calling functions to do all of that for you. And it's just not spatial. And then lastly, you are going to move or copy all the links that people have made to your node to some set of the nodes that you have now spawned. This is most equivalent to dragging function inputs or outputs to one or more of the blueprint nodes that we place on the graph. You won't have to do, you'll only do this for your set of nodes, so you won't do this a lot, but it's going to be an important step. Otherwise, there won't be any input from all those pins that you've already made to doing any of the work that you're making as part of expanding code. You'll want to come up with a way to organize this function. It is kind of a monolith, and it's going to have a lot, and it can have a lot of code. It can vary wildly in complexity and length. So for one option, you could you could call the super, do the error handling, spawn all your nodes that you need, get all the pins that you need, connect all the pins that you need, and then call this break all the node links function. That's one way to do it. Another way to do it is, so I call that one batched. I call this one interleave. Call the super, again, do the error handling, get your pins. You spawn a node, the next node that you need. You get all of its pins, and then you connect all those pins to previously spawned nodes. To maybe you do some of the moves from your nodes to the spawn node. But then you do all the work for one node, and then you move on to the next one. You spawn that node, get its pins, make links, and do that over and over and over again until you're done with the functionality that you call break all pin links. Personally, I found the second one to be the most understandable as you go procedurally through this expand node function. But ultimately, with a lot of code, you got to find what works for you. These are the two that but experiment. Again, figure out what works for you and how you write code and develop. Functionality, it's like a big part of the node. So we're on slide number 3 for functionality. So what are we actually going to be spawning with that function? Well, the most common one is probably going to be this call function node. This just lets you call blueprint callable functions from within your node. It's the node that backs most of the nodes that you place in the editor. Anything that you made a blueprint callable function, thanks Mike. Anything that you make a blueprint callable function when you place it in the editor, it's actually just, they're all the same one of this callable function. They're all parameterized specifically for the one function that you want to place in the editor, but behind the scenes for all of this. So, does order matter for any of this? Almost all of these problems you could fix with a function, but there's limitations of functions that you could do a function for this specific dialog box. But now do you want to do a function for every single dialog box in the game? There's better. So the power of these nodes. I present to you the open dialog custom node. This is where I should have had audio. Thus spoke there, Zarathustra or something. So, This is a node from my own personal UI library that I use for hobby projects. We do actually have something similar at Midsummer, though not quite the same. And it's a one-stop shop to doing modal dialog boxes within a specific UI framework. We've got the class picker and the expose on spawn pins, just like the create widget does. We have the parameters from the init function that are built right in, similar to the expose on spawn parameters. You can even make it dynamic enough where that init function is optional. Because you can write, your expand node is just code. So you can write code in there that's like, does this class have this function? Let me insert more blueprint logic. We've got the delegates, easily accessible and visible, so that when you select the class, you know exactly what information that you could be getting out of that dialog, as well as the specific types that each of those events are going to need, just like you would with a custom event node. As you change the class that's selected, all of the pins, except for the exec, the then, the class, and the owning player, all update. So as you change it, it's always going to represent the correct information for the class and the dialog box that you are trying to spawn at that moment. You can't forget to misorder anything. Initialization is going to happen correctly every single time. Some of it you might want to hide in the advanced section, and that's fine, but it's at least there and very easily accessible and visible. All the events are there, ready to be hooked up, and it's all very self-done. So now that I've hopefully convinced you that this is something worth spending your time doing, here's some helpful tips. And first, we'll start with answering Will's question about kind of the environment you're going to be working in. To start with, you've got C++. This is where eventually everything boils down into this C++. And these are your blueprint callable functions and the custom functions doing stuff in C++. Next, you've got the VM bytecode. This is where those F-node functor handlers and the actual blueprint VM does stuff. And this is what's actually run by the game at runtime. So a compiled blueprint is running this blueprint VM stuff. The generated graph is the first step in blueprint compilation and is the result of all of the expand node calls that happen from your custom K2 nodes, Epic's K2 nodes, all the expands eventually result in this generated graph. And this generated graph starts as a copy of your own blueprint graph, which I'll come back to in a bit. And then lastly at the top is the editor graphs, and these are what you're actually editing when you're in the blueprint editor. You're editing this custom graph, and then it's duplicated, and the compile process happens on this generated graph. I hope that answers your question, Will. So, a few things that can easily get you tripped up. Absolutely tripped me up at one point or another when I worked with these things. The first is that actual blueprint macros aren't going to be available. So, this is valid function, which provides you execution lines as opposed to just a Boolean. This is a blueprint macro. You can't use it in your custom nodes. Blueprint macros just aren't available for C++. The array for each, also a blueprint macro like I mentioned earlier, so it's not accessible from C++. Now, I haven't tried. Let's say that there might be a way to do it. It's probably not worth the effort. But I've actually rewritten both of these for myself as custom blueprint nodes, just so that for when they have been useful, doing my own custom blueprint logic. remember that your node will be in this uncooked only module, but that any of those functions that you call from the call function node need to be in a runtime module, which sounds annoying, and it can be a little bit. For node-specific runtime utilities, blueprint function libraries are great for this. They give you a place to just stick a bunch of functions to use and call from your blueprint nodes. You can make the functions private even so that your C++ can't call them if they should be calling better C++ versions of this function. There's also this blueprint internal use only meta, which makes it so that your blueprint callable function doesn't show up in the node dropdown, so that people will be forced to use your custom blueprint node to call that thing. It still needs to be blueprint callable, otherwise you can't use the call function node, but this at least removes it from confusion of both that function and your custom node being in that selection UI. There's a lot of different times that you're going to be dealing with when it comes to compiling and making custom blueprints. And you want to be aware of what time different things are happening. A lot of people get confused by the information that they want to have in order to affect their blueprint node isn't available at the time that they actually want it. So if you have a pin connected to a variable, you have the promise of a variable, but not an actual variable, which sounds weird, but you have to remember your game isn't running when you're editing the blueprint. So you kind of said, there is this variable, it doesn't have a value, we just have an int here. At runtime, when the game is running, it might be 12, it might be 50, but you don't know anything. So you can't do anything dynamic based on the value, only the understanding of it. And then, again, when expand node is called, there's a duplication before it compiles. The gotcha here is that anything not a U property won't get copied over. So if you've like cached values or something as a member variable, that won't get copied unless you make it a U property. It's also worth mentioning that those U properties are save loaded. Now, and some of that save load you might want to deal with the dynamism of your pin, but you also want to consider the other kind of normal tools that you would use for dealing with that dynamism, which I'll come to in a little bit. But it's something worth knowing. It hasn't bitten me too many times, but it's worth understanding for why your node looks like it's fine in the blueprint editor and then generates a compiler with some piece of information missing due to that copy process. So how can you figure out what you actually want to build? Since you're making a blueprint macro, Blueprint is a great prototyping tool. You can do it in blueprint functions, you can do it in macros, you can do it on the event graph. These can be great first steps in trying to figure out what that function should be. But even if it isn't quite as dynamic as what the final pin would be, as a reminder, this is what the for loop node is going to look like. You're going to be sick of this node by the end of the talk. And so here's what that node looks like if we were to make it in Blueprint. The comment block makes a great boundary for identifying what is the inside of your node versus the outside of your node. So expand node would be great creating everything on the inside of the node, minus the reroute pins. But the reroute pins do help, do make good placeholders for what your pins might be. You could do this
in an actual macro library as well, and it won't be exact. For example, the count variable, that's not how it works in the actual custom node, but that's how it needs to work to prove it out on the blueprint graph. For purposes of prototyping, you can leave out that blueprint internal use only flag so that you could place that node on your blueprint graph while you're trying to develop that functionality, and then add it back in when you commit your custom node so that the rest of your team doesn't see that function anymore. Eventually, you'll probably outgrow this. It's a tool. Eventually, if you do enough of these nodes, you might have a more intuitive understanding of what you're trying to build, how you need to build it, and you won't need to do this anymore. I don't do this anymore. I made this specifically for this talk to show you. Even with all that planning and intention, something might go wrong. So here we have a test case using that blueprint node, and we're just printing off, doing some print debugging. Under File, Developer, there's this flag called Save Intermediate Build Products. Super useful. This is only accessible when you're actually editing a blueprint, so just be aware of that when you go looking for it. If you don't have the blueprint editor open, you're not going to see this flag. But then when you compile, what you get is this, which you can't read, which nobody can read. But you can move, but these are just nodes. This is the generated graph. This is put onto another graph in your blueprint when you compile with that flag on. And you can move all these nodes around. And this is a great way to get an understanding of what the output of your node actually is, if it's giving you problems. Maybe you have a graph assistant kind of plugin to move all these things around. Maybe you've got to do it manually, but is super, super helpful. You'll notice, so there's this colored box way over here on this side that shows you the nodes that are just directly from the blueprint graph. And then everything else is some version of the nodes generated by somebody's custom blueprint node, yours or Evan's. When helping people online with some of this stuff, sometimes tell people when they're having a problem, you're like, hey, here's this flag, and then they use it. Almost invariably, they're like, mind blown, that is an amazing tool. I wish I had known about it significantly earlier when I was doing these kinds of things. A few quick tips for you. Take advantage of the engine source. Even if you're not building from it, it's available when you have the engine installed. It's great to use to learn to replicate features. If you know about a node, you can go look at that code and steal that functionality. That's how I built a whole bunch, most of these first things. It's just going to look at how does that node work? Let me steal that little bit of functionality. Usually it brings you to a new virtual function you can override, or something or an interface that you can use, something like that. So I said before, you don't have any runtime values available. But in the case of objects, as long as you have a type, you still have an instance with the class default object, which is great for compile time polymorphic behavior, where you can return a value based on the type. It's not dependent on runtime values, but if you always have a piece of information that is the same for every instance of a specific type, you can use that to inform a lot of your controls about your pin. Especially things like, if I put in this kind of class, maybe this other pin only accepts this kind of class. It makes it a way to make your nodes much more user-friendly and self-error handling. Hard coding values isn't a sin. You don't have to connect every pin from your inside, from what you're spawning, to one of your external pins. Pins have a default object, a default value, and a default text value on the pin. And this is basically what you would be filling in the little text boxes on the pins that you can type into. And you can fill those in directly inside of your expand node. Fair warning, the default value is a string. So if you want to hard code a Boolean, you're putting 0 or 1 or true false in quotes. You're putting you want pi, you're putting 314 as a string. So be aware that it can be, you want to be careful with doing that a little. U functions can be kind of useless, as I mentioned, since you've got anything you're calling would have to be in a runtime module. So adding U functions to your custom node isn't super helpful, except in this one case for delegate pins, because it means that you've got a specific function that you can look up that has the delegate signature that you want to use to initialize the pins or initialize the nodes that want U function to match some specific signature. You usually want to make sure that all of your pins, the ones that you've made and allocate default pins, are doing something. And you want to have them connected to something inside of the expand node on one path or another. This is why I cache them up front, is because Writer, probably Visual Studio, has nice UI and coloring that show you whether or not something is used. And so so that's a really easy way to do that check. You can spot check that with some find in files to double check that you're using all of your pins by the time you finish with expand node. The debugger and output window are incredibly useful. You can step through expand node. When it compiles, it's going to run. You put a breakpoint in there, you can step over every single line of code. And if something doesn't work, there might be something in the output that helps you figure out why. A lot of the time, it's maybe the difference between calling that a link to versus try create connection I talked about before. Just because the try create connection does a lot more to deal with dynamic pins on the nodes that you're using. And so sometimes using just make link to doesn't put the nodes in quite the right state. You gotta switch to the other one. Just because you're making these custom nodes, don't skimp on the U function markup. You can still make the U functions that you call, use things like the custom thumb, determines output type, expand as exec. All of these and any other of the markup are still useful on those nodes that you write to support your own custom node. They're super useful to make it the work that you have to do for your node less. If your node is going to have a bunch of exec lines that map to an enum, and you're calling your function anyway, have it use the expand enum as execs markup, so that all you have to do is connect those pins that the function already is going to have, instead of having to do your own switch statement after calling the function to switch on that enumeration. So, here's the lie of the API dump. We're gonna just quick hit a bunch of ones that are super useful. I'm not gonna go into too much detail on them though. This function allows you to this basically gives you a callback when node connections are changed. It's one of the functions that's super important if you want to do any of that pin dynamics, so that as people connect things to your pin, you can make changes to your node. You want to be careful not to confuse it with pin connection list change, which is another virtual function, but that calls notify. So you want to override notify and not the master control function. They didn't, from what I understand historically, if they were doing this now, the second one wouldn't be virtual anymore, but similar for the value change thing as the pin connections. If you're doing either of the other two things, this post-reconstruct node is what lets you restore some of that state that you would have done for those dynamic pins on load or copy paste, so that you don't have to necessarily stop your try to store anything on your node. This function is one you can override, just returns a bool that allows you to show that details panel. It allows you to do a lot more properties than you can do with that default only. And then there's a whole lot more display customization functions that you can use. There's other functions that you can override, or other classes that you can derive from. The create object from class does a lot of the class selection, dynamic pin creation for you. So it's a great place to derive from, to have it do a lot of that work for you. It has this create pins for class that lets you also create more pins than just what it would do by default. And if you use this one, you should also be aware of spawn bar pin that kind of filters which ones were generated dynamically and which ones were generated. It should always be there. This advanced API are just a bunch more functions that allow you to do like a right-click menu to limit where the node can be placed that I talked about, whether or not the pins can be connected to each other, the double click to go someplace, making things, if they're put into a macro, making the macro itself latent, making it look like custom events, and this is just a really handy structure type because they try to make strings a lot, and so you don't always want to have to redo some of that text work, and so they use this in a lot of their blueprint nodes so that you can create a cache and only update that text when it actually changes or when it does changes. And then here's a link to this presentation if you want it. I also have it on my phone. If you don't get it, I can get that for you. This is a link to my GitHub that has a bunch of plugins. One of them is a utilities plugin that, among other things, includes editor utilities for doing other crazy things with custom blueprint nodes, as well as Unrealist Matt's site, which compiles a lot of great details about various functions that you can call with custom K2 nodes, descriptions, listing out their parameters, and what they can do. And then I think that's it. So, if anybody has any further questions, we're not sure where exactly we are on time, Ryan, but all right.
Oh yeah, we're good.
Thank you.
All right. Any questions? No?
So you have to be using another source in order to create your own nodes? Absolutely. You could put that, you can make that Unreal module in any plugin that you want, while the PR that I made for the for loop for each node was in engine source. For as long as it was a PR, it was in the project plugin. It was actually in my plugin, one of my plugins that people were using. And so I actually had to deal with that when 5.6 added it and make sure that I didn't cause any conflicts there. But no, you don't have to put your custom node in the engine source at all.
Are you able to talk about the game that Midsummer
We're making, yeah, sure. We're making a life sim twist to it. So you develop, you create a cast of characters, you set up their relationships to kind of show that it is, and then you kind of let it run and direct it through telling them how to have conversations with each other, and television plots open up over time. Yeah.
I had a quick question. I mean, I don't use Unreal Engine, so this kind of thing.
Well, thanks for sticking around for the talk.
Oh, no, I mean, it's interesting. But I was wondering, like, who uses Blueprint, like, especially like in your studio, something like that? Is it for artists, people with programming backgrounds? Do they use Blueprints as well?
So it can depend on the project a little bit. Ultimately, for a studio that's using Unreal, everybody kind of uses Blueprint in some capacity. Even as an engineer who I know C++ kind of back to front, there's plenty of stuff that I still do in Blueprint because that's the right tool to do it in. It's more than a scripting language, but less than a script. Like it's in this. It does more than what a scripting language might do because you're building fundamental things for it. You're not just building one-off things for it. A lot of UI tends to have lots of portions in the Blueprint just because the layout tool for UI is in Blueprint, and so that's already an easier place to start. But yeah, and that's where its power is meant to be, where artists can use it, the designers can use it, engineers should be building with it in mind. They might even be using it for some of their actual work and their output. So.
One of the main reasons I was wondering is because it does seem like extending it the way that you did is maybe not completely outside, scope, but out of reach for.
Oh yeah. Extending it is absolutely not the what you would be expecting artists or designers or anything to do. They would be like, either they would be like, this workflow is terrible, and the engineers would make one. Or the engineers look at what the designers have built and be like, let's not do that. Let me build something for you better. We actually on on Marvel's Midnight Suns, we actually had that case where the designer was using the ability system to do specific changes to the game state because the abilities had a nice way to like configure that functionality. And so he was making all of these abilities that did one thing to use in one mission script in that one place where it's like, I need to very specifically do this much damage to this guy. And he was like making these one-off abilities that could only be used right there. And it's like, oh, that, like something about that just like hurts the soul, right? So what we were able to do was a custom node that kind of imported and did the same little, there were these little functor objects that the ability had for doing changes to the game. And so we were able to make a custom node that had that used the same functors to do, so that he could just come in and go, run this thing, do this check. And he didn't need the ability system to do that bespoke stuff. But yes, extending it is not the purview of everyone. Not even all the engineers. I don't necessarily want to do this.
Russell, there's like a difference between making a custom node and adding new nodes, right? Adding new nodes is easy to do just by putting new functions.
Yeah, absolutely.
You can add new nodes all day.
Adding new nodes with making them, as long as you, taking any function, having the U function markup on there and marking it as blueprint callable, that's enough to make a node in the editor. But that's, 90% of the time, that's what you want to do. You just need to take this function that's very simple, always has this output, that's gonna be most of the nodes and how you're gonna expose functionality in the blueprint. Absolutely. This is very much a corner case, very much a case of like running into uses that are just, that the U functions just don't quite do the job you want it to do. There are, just like with the for each, there are limitations to what it can do, and so sometimes you have to do something more complicated